I've long been fascinated by a proof that is attributed to Archimedes that relates the volumes of the cylinder and the sphere and the cone. So if you know in the height and the radii of all the solids, well, we have the standard expressions for what the volumes are. Pi r squared h, 4/3 pi r cubed, 1/3 pi r squared h. If we specify the radii of all these circles to be equal and the heights of the cone and the cylinder to be twice the radius, then that changes the expressions a little bit, and we end up with 2 pi r cubed, 4/3 pi r cubed, 2/3 pi r cubed, and we also know that 2 could be expressed as 6/3. So when we pile all these up, we can see that, in fact, 6/3 equals 4/3 plus 2/3, which is kind of handy. And so we just proved that the volume of the cylinder equals the volume of the sphere plus the volume of the cone. So I made this hourglass to demonstrate it. So while we have a minute, and we do in fact have a minute, this is a 3-chamber hourglass made for me by glass blowers in Berkeley. And it's a beautiful physical demonstration of a beautiful geometric property. But it does have a couple issues. Because if you had a pure geometric construction, you do have to, in fact, tuck the cone up into the sphere a little bit to get the sand through. And if this is full of sand, it would empty like that because cylinders have a flat bottom. And the cone, the sphere actually would clog itself by the pile that fills up, so that doesn't work either. So in fact, we have to separate these just an eensy bit and add an hourglass shape in between. So it isn't actually a 3-chambered hourglass, it's a 2-chambered hourglass, where each chamber is the same volume, and one is just far more interestingly shaped than the other. And that's it. Thank you. That's what I wanted you to see. You can't go the other direction. There we go.
Thank you, Ralph. You have just helped us out a lot.
Yeah.
There's $4.
Okay, great. I'll leave you with one puzzle. I maybe pay you $1 back, but they're, because we needed a 12 somewhere, place 9 of the pentominoes into those 3 grids. It's going to leave 3 pentominoes when you're done. So which 3 pentominoes do not fit when you do this? Thank you.